Topic for today's video is one of the most simplistic forms of prompt engineering, that is prompt prefixing, or it is also known as an efficient way to do zero-shot prompting. In this video, we'll be going through the introduction to or defining what exactly is zero-shot prompting. Then we'll be defining or coming to prompt prefixing. Post that, we'll be delving in some of the real-time use cases where we'll be discussing the difference between plain vanilla zero-shot prompting and how prefixing improves zero-shot prompting. These particular use cases then will be going through their practical implementation in a Python notebook. Coming on to introducing zero-shot prompting. So zero-shot prompting is a technique used with large language models or generative AI models to generate content. This content can be of any type, be it image, be it text, be it video, be it audio, or the codes in programming language. So zero-shot prompting is a technique used for generating any type of content using large language models or generative AI models without exposing the model object to any kind of examples for it to learn from, or without exposing it to any kind of training or fine tuning. The model only answers the question based on the knowledge it has been trained on, right? The pre-trained knowledge is the only reference for the model to give the answers of the particular query. This is what a zero-shot prompting is. It's a plain vanilla prompt given to the generative AI model, instructing it to do a specific task wherein the model is not exposed to any examples for it to learn on, or the model has not gone through any fine tuning or specific training on any domain specific task. This is what zero-shot prompting means. To give an example, let's say we have this prompt. As discussed in the previous video, the components of prompt, there are three components, that is input query, the second one is context, and the third one is the instruction. Over here we can use instruction or the prefix synonymously, they both mean the same. So the query is, we want to ask the large language model what are the causes of climate change, right? And the instruction is answer the question, which is this particular query, within the given context. The context over here is a paragraph related to climate change, an article related to climate change. What this means is that we are specifically asking the LLM to give an answer for the query, that is what causes climate change, and it should answer the question with this particular article as the reference. This is the scope of the answer. The answer should not go beyond the scope. So this question should be answered using this particular reference or context. The response is something, this is the kind of response that we get. This is a simple zero-shot prompting where we have given no examples to the model to learn from, or there is no fine tuning. Just based on the pre-trained knowledge of the model is giving out a response to the query, what causes climate change. Now coming to what is prompt prefixing. Prefixing, as the name suggests, is the practice of adding a predefined or a customized prefix to the user's input while making a request to the model, right? The only purpose of prefixing, that is improvising on the current prompt, is to produce responses that are coherent, relevant, and contextually appropriate. That is, if we modify the prompt, if we add a certain amount of prefix, it will help the model to create an output which matches the user expectations, or it can help improve the quality of the model's output or the model response so that the user's expectations are matched. This is what is meant by prompt prefixing, adding a prefix into the prompt so that the model output enhances. Now to understand better what's the difference between the output generated via a simple vanilla prompt, zero-shot prompt, versus a zero-shot prompt that has been prefixed or the prompt has been enhanced, right? We'll consider this example wherein we have these three components of the prompt, that is the query, we have the context, and just the prefix or the instruction to the model have changed. On one side we have the plain vanilla zero-shot prompt, on the right hand side we have the enhanced prefixed prompt or a zero-shot prompt where the prefix has been enhanced. Based on the context, we are asking a query to the LLM that what is the world's population in 2022. We'll go through the part where this question can be answered from, which is this: world population was 7 billion in 2010 and it has grown 50% in 2020. It increased another 10% in next 2 years. So in 2010 the world population was 7 billion. In 2020 the world population increased by 50%, and within next 2 years, that is 2 years post 2020, that is 2022, it again increased by 10%. So to calculate the final population, we'll have to compound 7 billion with 50% and 10%, right? If we ask a simple vanilla zero shot prompt, this is what the response we get. The vanilla prompt or the prefix is answer the question given the context. Plain vanilla prefix or a plain vanilla prompt gives a response, a wrong response, that is 10.5 billion population, which is a wrong response. Coming to the enhanced prompt or a enhanced prefix, wherein we are asking specifically the model to behave as a mathematician, that is giving a persona to the model, right? Because the work of a mathematician or a profession of a mathematician is to solve complex business problems related to mathematics. This is exactly why we are giving the persona of mathematician for the model to solve this particular problem, because it's related to mathematics. In this particular case, the model is giving a correct output of 11.55 billion. That is 50% increase from 7 billion would be 10.5 billion, and then again a 10% increase on compounding on 10.5 would be 1.5 billion. The addition would be 11.55 billion population, which is a correct answer, and it is giving us a step-by-step solution. This is the power of prompt prefixing. Coming to the second use case on understanding the difference between the output of an enhanced prompt, that is a prefix prompt, versus a plain vanilla prompt, we have a text summarization use case where we have the same three components: query, the context, but the prompts are two different prompts. That is, one is the vanilla prompt and the other one is the enhanced prompt. We are asking the model or the LLM to summarize this particular article on climate change. If we give a plain vanilla prompt, that is answer the question given the context, the question is summarize the article, the LLM would summarize it well, but it will summarize it according to its own will. There is a possibility that it won't match your expectations. Hypothetically speaking, let's say your expectations were that you wanted to summarize this particular article point by point based on the format below. That is, you wanted it to be a structured summary with specifying these three particular points, that is major cause of climate change, other reasons for climate change, and increase in the population over the years. Since you want this in this particular kind of a pointed structured format, you ask or prefix the prompt in that particular way, ask the model explicitly to do so, so that it will give you the expected output that matches your expectations. The user expectations are matched because you are prefixing the prompt, whereas in the left side where you are giving a vanilla prompt, the summarization of that particular article is done purely based on the will of the model and not matching your expectations. Now coming to the last part, wherein we will be implementing the use cases that we just saw, the theoretical use cases that we just saw practically using a Python notebook. First, we will be installing OpenAI, because the LLM that we are using to solve this particular use case is GPT 3.5 Turbo, which is a proprietary LLM of OpenAI. Hence, we will be installing OpenAI library and importing the same. The next thing we will do is we will define our API key, because we will be solving this problem via a API call to OpenAI infrastructure where the GPT model is hosted. For us to access that, we need a appropriate authentication token so that our request passes through the API and gets us the response. Then we'll be broadcasting our key for further use, further referencing in the notebook. Coming to the first function, that is LLM request function, which we have defined so that we can send a request to an LLM which has been hosted on the OpenAI's platform using a API interface. To do that, the first thing we'll do is we'll define or initialize a OpenAI client object This client object will help us interact with the OpenAI's API. Now, secondly, since we want to have a chat conversation between between the user and the LLM, because we want to send in a query and we'll expect a response in the form of chat completions, we'll be doing that using this particular line, that is client.chat.completions.create. In this particular function call, we have these parameters, that is, the first one is model. This model can be anything of your choice. Here we are using GPT 3.5 Turbo. You can use GPT 4, 4.0 or 3, whichever suits the purpose. Then coming to messages, this is an array of messages that are sent to the model. Decoding this, we have two dictionaries over here. Each dictionary represents a prompt. The first dictionary is essentially a message. This message sets the system prompt for the model. Since the role over here that is mentioned is system, it will be a system prompt, and it is asking the model to behave as a helpful assistant so that it can assist us with answering the queries in the form of chat. We'll give the input, the assistant will help us get the output. The second prompt is a user prompt, which is asking the model to give the user output with respect to the query that has been asked. The query will essentially be the part of the dynamic prompt, which is given as an input parameter in this particular function. Now coming to the second function, that is a prompt creation function. That is a user prompt creation. The query or the instruction that we want to give it to the model, that is, which will go in this particular prompt dynamically, we are creating it over here. As discussed in the previous video, wherein we have three components of the prompt, namely instruction or the prefix, then we have the input query or the user query, and we have the context. These three are given as the input parameters to this function dynamically, and we create a prompt which is passed to this particular function as an parameter. And finally, this prompt goes in the user prompt to the model for referencing via the API interface and get us the final output. Now coming to the first business use case, wherein we had the article, the climate change article as the context. The query that we asked the model to solve was what is the world's population is in 2022, and the prefix or the instruction that we gave the model to follow is answer the question given the context. The context over here is the article related to climate change. What we'll do is we'll just pass these three parameters as the input parameters to prompt creation, which will essentially create a dynamic prompt, and this prompt will be passed on to the ChatGPT 3.5 use LLM function, which will help us get the output or the response using a API interface to the OpenAI's infrastructure. This is the whole process flow. Now coming to this example, wherein the query was what's the world population in 2022, and we ask a vanilla or a simple prompt, that is answer the question given the context, we get a wrong response. The second or the enhanced prompt or the prefix prompt that we asked in the example was act as a mathematician, giving the model a persona to answer the question given the context, and we do the similar process as we did above, only changing the prompt or the prefix, where we ask the model explicitly to adopt a persona of mathematician. That is the only change. We pass it to give the response, and we get a response that is a correct response of 11.55 billion with the explanation, step by step explanation. This is the difference between a prefix prompt versus a vanilla zero shot prompt. Now coming to the second use case, that is summarization use case, text summarization. The overall process remains the same. The query over here changes, that is we are asking the model to summarize the article, the same article, the climate change article that we saw in the earlier use case. We are asking it to summarize it. This is the query. The context or the article remains the same. The first prefix that we use is the vanilla prefix, that is answer the question given the context, and we pass these three as the parameter, input parameter to prompt creation, and we get the response. This response is a correct summary of the overall article, but the only thing is it is according to the will of the model or the large language model. According to it, it has given a summary. But now let's say we wanted a structured summary which we had in mind given these 3 pointers explicitly. So what we do is we give a templatized prefix or an enhanced prompt so that the model understands what are the requirements. That is, it should be a structured format with these 3 pointers in the summary. We repeat the same process and we get an output which matches our expectation, a structured summary. This is again where we see a difference between the plain vanilla zero shot prompt versus a prefixed or a enhanced zero shot prompt. Please do not forget to like the video and subscribe to the channel for more such informative videos related to artificial intelligence. Thank you.